All right, let's dive into a story that honestly sounds like it's straight out of a movie. The headline says it all: the day the Mediterranean turned into a hurricane. Just let that sink in for a second.
I mean, that's the first question that pops into your head, right? Can a hurricane actually form in the Mediterranean? You know, when we think of hurricanes, we picture the huge tropical expanse of the Atlantic Ocean, not the calm, ancient waters of the Med. The whole idea just seems wrong, impossible even.
And for centuries, you would have been right. For a very long time, the answer from pretty much everyone, scientists, sailors, you name it, was a firm no. But well, it turns out our planet is starting to rewrite the rule book.
So let's start by looking at a storm that just completely blew all those old ideas out of the water. An event that forced us to look at the sea in a totally new and frankly, kind of scary way.
And check out how unbelievably fast this thing develops. On day one, it's just a little bit of a weather disturbance off Libya, no big deal. By the very next morning, it's exploding in strength over warm water. And get this, by that same afternoon, it has that classic, unmistakable eye of a hurricane. Then, less than 3 days after it even formed, it's slamming into Greece as a Category 1 storm. We're not talking about the slow, week-long crawl of an Atlantic hurricane. This is a pop-up storm that goes from 0 to 100 in no time.
And if you're thinking, oh, it's a mini hurricane, how bad can it be? Think again. We are talking about wind gusts hitting 125 miles per hour. That is absolutely destructive power, all packed into a tight, compact storm.
So this brings us to the big question. If it looks like a hurricane, if it has the power of a hurricane, what exactly is it? Well, let's break down the science behind this bizarre phenomenon they're calling a medicane.
Okay, so here's the textbook definition. The name itself, you can probably guess, is a mashup of Mediterranean and hurricane. And that name is perfect, because it really is a hybrid. It's this strange meteorological beast that has feet in two different worlds, borrowing traits from two completely different kinds of storms.
So let's put them side by side. You've got your classic hurricane over here. It's huge, it can last for weeks, and it's powered by what's called a pure warm core. Basically, it's a heat engine running on tropical ocean water. But then you have the medicane. It's smaller, it lives a much shorter life, and has a hybrid core. That means it's getting energy not just from the warm sea, but also from the clash between cold air from up north and warm air from the south. It really is like a hurricane's smaller, faster, and way more unpredictable cousin.
So we know what these things are, but the real mystery is why. Why are we seeing them now, and why are they getting stronger? Well, the answer isn't really in the sky, it's in the water. This chart tells so much of the story. It's simple, but it's powerful. You can just see that steady, undeniable climb in the average sea surface temperature. From the 80s to the 2000s to today, it's just going up. And all that extra heat, that's pure energy. It's high-octane storm fuel just sitting there in the water, waiting for a spark.
And that spark brings us to the recipe for one of these things. First, ingredient 1, you need that deep layer of warm water we just saw. That's your engine. Second, you need that spark, which usually comes from a blast of cold air diving down from high up in the atmosphere. And finally, the crucial third ingredient, low wind shear. That just means the winds at different heights are calm, which lets the storm stack itself up vertically into that classic, terrifying spiral shape.
So what does this all mean for the future? I mean, this isn't just a cool science fact. This is a new and pretty dangerous reality for the millions upon millions of people who call that region home.
And the real-world consequences are what really matter here. We're talking about a huge risk of flash floods in ancient coastal cities that were never built to handle that kind of water. We're looking at massive hits to shipping and tourism, which are the lifeblood of so many of these economies. And what's really heartbreaking is the incredible danger to the thousands of priceless historical sites that have dotted these shores for millennia.
And this isn't just speculation. As this climate scientist puts it, the Mediterranean is a hotspot. It's a part of the world that is warming up much faster than the global average. In a way, it's acting like a canary in the coal mine for what the rest of the planet could be facing down the road. Which brings us to this final, really sobering question. For thousands of years, the Mediterranean Sea has been called the cradle of civilization. But as the sea itself is fundamentally changing, what happens to the civilizations that have always lived on its shores?